Parmigianino's self-portrait in a convex mirror in the Kunsthistorische Museum in Vienna. He was 24 when he painted this in Rome, and it caused a scandal, these incredible distortions. And Vasari assures us this was executed when Parmigianino saw himself in a barber's mirror, a convex mirror. You've all seen these mirrors in convenience stores and in blind driveways and so forth to get a wide-angle view of the world. And that's what gives us all this distortion. But the question is, how much, how fictive is it? In other words, did he accurately reproduce what he would have seen in that mirror, or did he sort of make it up and just distort things? Well, this is not on canvas, it's on wood. And it's not on flat wood, it's on bowed wood. It's on a section of a sphere that was cut for him. And so he's clearly trying to duplicate the experience of seeing himself in this convex mirror. But we still haven't yet answered the question whether there's a plausible room. Can you really get a window to tip over something like this? Now notice this. This is the actual painting itself that he's working on, right? That is this. He's looking at himself in a mirror, and off on his right hand is the painting. There it is. And now we're looking at it. Think about it. Here's our, this will be clear, right? So he's looking at himself in a mirror, and then here's the painting that he's working off. He then moves his right hand over and starts painting here. So there's the mirror, and there's the painting. And we saw reflected in the mirror the painting, right? You see it here. But now we, in computer graphics, can adjust the radius of curvature, the bulginess of the mirror. And that will change the image, of course. And then we can adjust the parameters and see if we can create a rectilinear room and a curvature of the mirror and that matches, so as to get a painting that matches what we actually see. And what we found was, indeed, you can. Moreover, that the curvature of the wood support, as it's called, was within 10 or 15% of the curvature of the mirror that he would have had to have used, as far as we can tell. So it was a very tour de force result. But this has import for how this is displayed in the museum, in the Kunsthistorische Museum in Vienna. I'm 6'2.5" feet tall, and this is Europe, so I'm 190.5 centimeters high. My eye comes up to about, in 2009, comes up to a little bit below the center of the curvature. And I hope you can see that it is somewhat bowed. You see how the museum lights are reflecting off the top here. Again, the support is bowed. I claim that this painting has been mishung in the Kunsthistorische Museum for 65 years, never been properly displayed. Moreover, that there is no correct photograph of this book, of this painting, in any book whatsoever, as far as I can see. Why? Because my eye is at this height, and every photograph of this painting shows it straight on. But instead, the way Parmigianino would have seen it when he executed it, and wanted us to see it, as in the museum now, is the following. That here's the center of curvature of the support, of the sphere, if you will. Here's the position of the eye, the painted eye of Parmigianino on the painting, and here's where our eye should be. These should be along a straight line, because you would see yourself reflected, your eye in the position that obscures the center of curvature. So I went to the garden, I borrowed in the museum, and I borrowed a chair, and I stood on top of it, and I closed one eye, and I put my eye in the position that, in this position, and the painting looked better. It looked just so much more real and convincing, as if I'm looking at a mirror. So, so here, that's the photograph I just showed you, 2009. So I wrote this paper. I sent it to the chief conservator, Elke Oberthaler, and I happened to be in Vienna last year, on the dissertation committee in Vienna. So I thought I'd go to the museum and see if they rehung the painting based on my suggestions, and they did. So if you go to Vienna and see the painting properly now, you can thank me. But this has more import, has import elsewhere. In terms of the history of the development of Western painting. If you think of the period before this work, it was the High Renaissance. Think of Leonardo, Virgin of the Rocks. He was such a careful observer of nature, and he was striving to reproduce shading and light, effects of light and flowing water and so forth. But the next period of art was called Mannerism. And if you think of El Greco with these incredibly distorted figures, there's no attempt to reproduce nature the way, for instance, Leonardo and the other artists of the High Renaissance did. So this is, in some sense, art about art rather than art about nature. And right at this juncture, right at this transition, is our painting, Self-Portrait in a Convex Mirror. And so now there are many possible, there are many sources of forces that led to this change involving, loss of certainty in nature of reality and so forth. But the question is, was this distortion here out of Parmigianito's mind, or was it due really just to optics? And our results show that it was due to optics. That's a small piece of this big transition, but I think we've really pinned down the effect, some of the influence of this particular painting on the history of art. Now, one of the joys of working in this field is learning of questions from the art community. So I gave my lecture on The Girl with the Pearl Earring, and afterwards, Petra Noble, the chief conservator at the Maritz House, said, "Oh, come back to the studio. I'd like to show you this painting." I'd seen Jan van der Heyden's work before, but I didn't know there were any technical questions to be asked about it. She said, "Well, van der Heyden did a lot of brickwork, and there are lots of teeny little bricks, thousands and thousands of bricks, and they are done, as the curators and conservators would say, very securely. You don't see smudges. It's so compulsive to get it just right all the way through here." And for a number of reasons, there was some scholars put forth the idea that he used a technique called counterproofing to do it. He didn't paint them by hand, but instead he did, it's called an intaglio, but you take a metal plate and etch the mortar work pattern in, then white paint onto it, take this and press it and print it onto a piece of paper, then take the paper and press it against the painting. And in that way, you would be very secure. Any smudges that you had ahead of time, you could fix, and you wouldn't have to worry about making the errors there. So the conservators said, well, if he did that, maybe he reused some of the brick pattern. He used the same metal plate. And so maybe this pattern appears somewhere else. Hard to detect that by eye, but very easy by computer. So we did simple image analysis to segment out, to isolate the brickwork. And then we're not interested in the horizontal lines, because those are going to repeat everywhere. Those are going to line up everywhere. We're only interested in the vertical segments. And so we use what's called a structuring element. We take the brick pattern and we convolve it with this, and it just picks out wherever there's vertical segments like this. So the vertical part, that's the pattern that we're looking at. And so here is the result for that segment, and here's sort of a detail of just that. And so we can now take this pattern and search all the way through. It only takes 2 hours on the computer, laptop computer, and searches all the way through and says, are there any such patterns that overlap and match highly, accurately? And that's representing what's called a parallelogram. And these are the peaks. It says, oh, if you shift one thing here and over here, how the quality of the peak is how high it is here. Well, it turns out that we could not find any pattern that matched perfectly. But we are now moving on to looking between between paintings, seeing if one of the patterns on painting number 1 appears in number 2. And we're now just getting the data to do that. I didn't know this was a problem, but we're working along with art historians and conservators in order to answer those kinds of questions. We've also worked on Van Gogh's brushstrokes. Here's Self-Portrait of the Great Feldhaven in the Van Gogh Museum in Amsterdam. Every one of us can look at a pattern like this and see, oh, there are many layers of brushstrokes, the blue, the dark ones, and we can clearly see that the red brushstrokes are on top. Wouldn't it be nice to see what the painting looked like before Van Gogh put on that last layer of brushstrokes. Well, I won't go through the full algorithm, but we have a method to do that. Basically, it looks at a patch and it finds out how many layers there are by how many colors there are. If there's red and green and blue, well then there are probably just 3 layers. The trickiest part, and the part we're still working on, frankly, is figuring out automatically which layer is on top. So if you have one layer of brushstrokes like this and another on top, if you look at the lengths and the spatial statistics of the layer on top, it's going to be very uniform. They're almost all the same length, whereas something that's been chopped up because of something occluding it will have some long sections, some short sections, and so forth. So we have a mathematical formula that says whether, that sort of tells, not 100% yet, whether something's on top. Well, once we've decided what's on top, the red layer, it's very easy in the digital image processing to pull those away. And then we have to in-paint, we have to fill in the colors behind it. And so here's our sort of results, here. So the red layer is determined on top, and we pull that away and flow the data in like this. So this is an estimate of what the painting looked like before Van Gogh put the last layer on. And then, of course, we can do it again. And we can do it again. And we can do it again, and again, and again. Each time, peeling off another layer of paint. Now, of course, there are going to be more and more errors because we're propagating errors as we go all the way through. So at the bottom, it's not going to be, highly reliable, but the principle holds. And then we can make our movie go backwards. We can first show this, then this, and this, to see the painting develop, as they say. Sort of like standing next to Van Gogh, watching his canvas as he paints. So here goes with this, layer after layer after layer after layer. And so it helps art historians see what the painting looked like when Van Gogh decided to put on the red layer and so forth. We're not using any X-ray information or infrared reflectograms. The techniques for seeing behind this is all based on the digital file of the image. And then, of course, it only works for paintings where we have open brushwork, where we can see the multiple layers. It wouldn't work whatsoever on something like Vermeer.